Okay. Well, welcome everybody to the afternoon session, the first one after you've finished what is probably a very calorie-laden lunch, so I hope most of you manage to stay awake as we go through this presentation. My name's Rob Rosen. I lead the America's Solution Architecture team for Mapbar, which is a Hadoop distribution provider. And I'm going to talk to you a little bit today about how several of our customers, not just one customer in particular, but several of our customers are actually integrating legacy enterprise data warehouse environments with Hadoop for huge financial and productivity advantage. But before I get started, I'm kind of curious. I just want to do a level set. How many of you guys are actually running Hadoop in production with production workloads right now? All right, good. So of those of you who are running it with production, are you actually engaging or integrating with enterprise data warehouses as data source? Okay. All right, good. So you're in the right place. So what I'll do today is I'll talk a little bit about sort of the dynamics around why people are interested in looking at enterprise data warehouse, specifically ETL offload with Hadoop as a core Hadoop use case. We'll talk about a reference architecture that we've seen many of our customers actually deploy in production, and we'll talk about some of the financial advantages they're getting out of that. And we'll also introduce this concept of an enterprise data hub, which is actually pioneered by a guy named Mike Ferguson, one of the original Teradata architects. So we'll go through those things. I'll try to leave a couple minutes for questions, and I'll stick around afterwards in case we run out of time. So let's see. So before we kind of get rolling into the meat, I'll sort of do a little bit of a level set for you around who Mapbar Technology is. We are an enterprise-grade Hadoop distribution provider. So we actually are working with many customers around the world in multiple vertical market segments, deploying Hadoop in production in very productive ways. We've been in business for about 4 years, and we've been selling our product and supporting it in the market for 2 years. In those 2 years, we've actually deployed in production at 12 of the Fortune 100 across multiple different vertical markets, which I think is a pretty impressive statistic for a relatively young company. And if you look at who's actually deploying Hadoop in production in terms of a market segment focus, the early adopters for Hadoop have traditionally been the folks in the advertising technology space because they have a very, very big job, and really Hadoop is the only technology that has been proven to scale wide enough to allow them to support the analytics they need to drive for their business. Many of the pioneers in the advertising technology space, such as Comscore, Rubicon Project, many others that we can't quite name yet, they're actually using the Mapbar distribution of Hadoop, and they're doing that and running their business on it because they tried and failed to do that with other distributions. So that's kind of the hallmark of what we do. We're about enabling true enterprise-grade production workloads with Hadoop. And another sort of data point I have on here I'll throw out is we've also got many customers in financial services and retail. And if you look at the footprint of the data that they're analyzing on a day-to-day basis, they're touching about $1 trillion worth of financial transactions that are in some way, shape, or form getting loaded into a Mapbar Hadoop cluster. So there's a lot of analytics going on around retail transactions that are being powered by Mapbar. And that's a pretty strong data point, I think. Okay, so presumably most of you have heard or seen this concept of the 3 V's, volume, variety, velocity. Those are sort of the dynamics that I think IBM actually coined to define what big data is really all about. And the interesting thing about these 3 V's is it's providing or really generating very specific pressure points on folks who are trying to run enterprise data warehouses and engage them with Hadoop as a technology. So from a volume perspective, those of you who are familiar with enterprise data warehouse structures know that it's actually quite expensive, relatively speaking, to store and process data in a data warehouse environment. We've got some figures that we'll share with you a little later on in the presentation that speak to that. So when you've got a huge increase in volume over your traditional data sources, that's driving a lot of pressure from a financial perspective on folks who are responsible for enterprise data warehouses. From a variety perspective, as you probably know, enterprise data warehouses are typically powered by relational database backends. Those require you to structure data before you can actually do analytics on it. But the fact of the matter is that the vast majority of data that's being generated these days is machine data, and it's typically semi-structured or unstructured. So folks who are responsible for enterprise data warehouses really struggle with trying to reconcile the sort of enforced relational structured system that they're required to deal with against this gigantic volume of unstructured and semi-structured data that's coming in over the trenches. And then finally, speaking of coming in over the trenches, it's a huge variety and velocity of data. The volume is coming in very quickly, and the speed is really overwhelming a lot of folks who are responsible for enterprise data warehouses. So when I talk to customers in the field, which I do often, obviously as part of my role, the sort of emotional feeling I get from them is they just feel completely overwhelmed. There's just way too much data coming in over the trenches. They don't really know how to structure it, deal with it, process it in a productive way, and it's just a huge problem for a lot of folks. So that sentence, too many different types, sources, and formats of critical data, that's a sentence that we're hearing every day from our customer base. And that's just, a fact of life. Everybody's pretty much having to deal with this, and it's largely spurred by the growth of unstructured data formats coming from devices. So now the question is, all right, well, what can Hadoop do for me to help kind of get through this problem? And presumably most of you are familiar with some of the fundamentals around Hadoop. There are some technologies that are included as part of a Hadoop distribution, notions like MapReduce, the original big table concept, the Hadoop distributed file system. These are all concepts that were fomented or originated at Google many years ago before they were sort of packaged up and taken to the market in an open source format through this concept of Hadoop. And the sort of built-in parallel processing capability you get with this sort of structure really allows you to potentially process huge volumes of data in a much more productive way than what you have with your traditional legacy technologies. And the real driver about this is that if you look at financials, if you can drive an open source model on top of, commodity hardware, that's a huge potential cost advantage over what you might be dealing with in a traditional enterprise data warehouse environment, which is much more of a proprietary format. So we'll talk about some of the economics associated with that disparity in the next couple of slides. So the data on compute model, which is part of Hadoop, that really is one of the huge technology enablers that allows Hadoop to add value in a data warehouse construct. The whole notion here, in case you're not familiar with it, is that by co-locating compute and data, you avoid the need to actually having to transit a network when you're computing these queries. So it's a much more efficient processing model. It takes advantage of the commodity hardware that's out there to really sort of generate these queries potentially much more quickly than what you might have with a traditional enterprise data model or enterprise data warehouse model. The other sort of really interesting aspect associated with Hadoop is that because you can actually ingest your data and store it in an unstructured or semi-structured fashion, basically in its native format, you don't have to worry about pre-configuring your queries and stripping fidelity out of the data by structuring it first. And what that allows you to do is to go back and query your data in different ways after the fact. So a lot of folks who work with data warehouses are telling us that they have to worry about the sort of structuring process, removing fidelity to the point where they don't have the ability to go back and ask different questions later. And that's a huge restrictive issue for folks who are responsible for data warehouses. If you can find a way to leverage Hadoop to actually get around that problem, then you have much more flexibility and you can do things like long tail analysis and what if scenarios much more effectively. The sort of hallmark of Google has been this expression, simple algorithms with huge volumes of data trump complex algorithms. We hear that repeating over and over again with our customers who have deployed this model successfully in an enterprise data warehouse fashion. So there's no substitute for actually computing on all the data as opposed to just a sample of the data. In fact, one of our customers, just to kind of throw out a data point, they're in the retail business. They have taken historically a sampling approach when they weren't dealing with Hadoop to try to do fraud analytics. And that sampling approach is fraught with peril because you're sort of deliberately picking subsets of the data and hoping that they're representative of your entire data model. And they couldn't actually ingest all the data because it would have taken them 4 months and a whole bunch of computing capacity they didn't have in their data warehouse. They've actually used Hadoop to ingest all of that data, which has dramatically improved their ability to get much more accurate fraud analytics done. And they can ingest and process all that data in 6 to 8 hours now with Hadoop as a front end. So this is a huge business enabler for them. It allows them to be much more productive with their business and much more accurate about their fraud analytics process. So this is a graph that we often put up in our presentations just to illustrate that of all the different sort of interesting cutting edge technologies that are out there, there's way more demand for Hadoop from a job perspective than there is for maybe some of the more traditional NoSQL approaches. So if you're wondering, what is the best technology to use to help solve some of these problems, the market's telling you it's Hadoop, right? That's where the demand is. It's basically a 10x demand in terms of open job positions over some of the more specific NoSQL technologies like MongoDB or Couchbase or whatever's out there. Okay, so if you look at sort of the traditional data warehouse deployment model, you typically have source data, which historically has been transactional in focus. And then you have this sort of analytical layer where you're ingesting a lot of that data directly, historically, into a enterprise data warehouse and some sort of associated technologies like data marts. And the sort of pressure that a lot of our customers are seeing is as that source data, the traditional relational transactional model data is increasing, that's putting a lot of operational pressure on your data warehouse. And if your data warehouse is already running pretty hot, if maybe you're running at 80, 90% of your capacity, And when you start to throw in things like unstructured data, which is a much larger volume and variety and velocity of data, then you run the risk of literally knocking your data warehouse over. And some of the operational issues that we hear from our customers are things like, well, you know, I'm in the telco business. I'd like to be able to acquire more companies, but I can't do that because my data warehouse is running so hot, I don't have the ability to incorporate any more data sources from billing systems. So there's a lot of interest around trying to reduce the operational pressure in your data warehouse by finding some way to leverage technologies like Hadoop to lower the temperature and free up some computational headroom and storage headroom that allows you to do the core business of a data warehouse much more efficiently. The other sort of dynamic we often see is customers tend to load all their data historically directly into a data warehouse, but then over time, much of that data cools down. So your hot data set is actually only a fairly small subset of the data that's being stored in that data warehouse. So you get this inadvertent bloating effect where you've got all this data that you're not actually needing to process from a hot data perspective on a daily basis. And that's driving a lot of the storage costs up as well as the sort of processing time tends to drive much higher as well. So finally, sort of the other operational issue that we see from our customers is they typically structure their ETL process during off hours. So you've got a fixed non-production window to get your ETL done, and that's typically done at night. But because the data volumes are growing so quickly, you're running out of night. So you literally run out of time. You can't finish your ETL process on the window that you have available for you. So that's creating a very significant operational threat to the business. It's more than just a technology challenge. That's a business challenge. So here's the dynamic that we're actually seeing our customers really start to adopt as a kind of a first primary use case for Hadoop. In our experience, there are a lot of different use cases that people look at when they first step out with Hadoop, but actually leveraging Hadoop as kind of a front-end model for data warehouses is often the first place that many of our customers go because there's tremendous cost savings, and we'll talk about what those are in the next couple of slides. But basically, the model here is that instead of ingesting your data directly into an enterprise data warehouse, actually, a lot of our customers are ingesting it primarily initially into a Mapbar cluster, which is front-ending the data warehouse. And then they take a subset, not necessarily all of the ETL process, but a subset of the ETL process and run that directly on the Hadoop cluster. So that allows you to do a couple of different things. Now you're ingesting your data in its pristine native format into a Hadoop cluster. You can go through the ETL process on your Hadoop cluster, go through the structuring exercise, then load the structured data into the data warehouse, but all of your original data is still in the enterprise data warehouse hub, which is the Hadoop cluster that we'll define in a few slides here. So the idea there is that now you've got all of your data landing in a Hadoop cluster instead of directly in your enterprise data warehouse, and you're only formatting and structuring some of that data to go into the data warehouse. So that's the incoming dynamic. The outgoing dynamic is you can also use this cluster as a sort of long tail archiving platform. So for the data that you don't need to keep in your data warehouse, you can run it the other way, store that into your Hadoop cluster, and run Hadoop-based analytics on it over time. So you get a real advantage in this model in the sense that you now can actually offload the ETL processing and offload the storage associated with the data warehouse model onto a Hadoop front end where you have a much lower cost structure. And I'm going to go through a couple of slides here in the next few minutes that will actually illustrate the significant cost difference associated with this. But the real beauty of it is that you can deploy this approach in a very non-disruptive way because typically the rest of the processing pipeline, if you will, where you've actually got enterprise BI users looking at their data on a data warehouse, none of that has to change. So you can deploy this whole model in a very non-disruptive way without sort of telling your end users to drop all the tools that they're used to using. They can still use the same tools. They can talk to their traditional enterprise data warehouse data sources. And with our distribution for Hadoop, you can also do queries directly on the Hadoop cluster as well. So it's a very non-disruptive way to run this play, and it really lowers your costs. And I'll sort of bring up some data points on the slide here. So I come from the storage business. That's kind of my background. And one of the metrics that a lot of storage people focus on is cost per terabyte. So there's a lot of arguments around exactly what does it cost you to store a terabyte of data. And frankly, I was kind of shocked to discover the price differential between what it costs to store a terabyte of data on a data warehouse platform versus what it costs to store it on a commodity hardware Hadoop type platform. And we're looking at multiple potential orders of magnitude here. So when our customers go through the process of actually determining, well, what makes sense for me to do an initial play for Hadoop, they look at this cost differential, roll up the numbers and go, you know what? I could save $30 million over the next 5 years by reducing the amount of storage pressure I'm putting into my data warehouse. And that's a huge cost savings, right? That's a way to get a very quick approval of your IT project. So that reduction in CapEx and OpEx associated with offloading all the storage off of your traditional enterprise data warehouse environment and putting a lot of that ETL process on a Hadoop front end that's powered by Mapbar, that's a huge cost advantage. So from a sales perspective, I support a very large sales team with my engineers, and we run this play all the time because it's a very quick ROI, and it's a very easy way to get a project greenlit, and it's actually a fairly non-disruptive way to deploy a solution like Hadoop into the enterprise. So these figures right here are extremely powerful, and that's driving a lot of the interest around running this particular play. Okay, so it's not just Mapbar who's actually running this play. All the major Hadoop distributions are running this play as well. So you might want to ask, well, why would I want to run this play with Mapbar as opposed to, Cloudera or Hortonworks or just stock Apache for that matter? And really what it comes down to is the ability to support this data in an enterprise environment in a way that actually is facilitating long-term usage of the model. And what I mean by that is if you look at an enterprise IT environment, which most of you are probably working with, the real trend around adopting new technologies is enterprise readiness. If you're going to deploy a new platform to the enterprise, there are certain rules that you have to play by. You've got to be able to deliver a 5 nines level of availability. You have to have built-in data protection models, so when somebody accidentally deletes a couple of terabytes worth of data, you can recover it quickly. You need to be able to enable disaster recovery as part of your major paradigm. All these are sort of like table stakes for any new technology in the enterprise. And that's something that comes out of the box with the Mapbar distribution of Hadoop. With other distributions, they typically try to do it in a bolt-on way, and it doesn't tend to work very well, which is why our customers have been moving to us from other platforms. So this sort of ability to deliver a sustainable enterprise-grade, what we call actually an enterprise data hub, if I can get my slide to move forward, here we go, is actually a huge enabler for us in allowing our customers to be successful with this particular kind of a paradigm. And this isn't an expression that we actually invented. The enterprise data hub is a notion that Mike Ferguson from Teradata actually came up with. And he has pioneered this whole idea of sort of socializing, putting all your data basically in one place that allows you to sort of run analytics off of a single platform. And it's a pretty powerful notion, which a lot of our customers are leveraging because they're actually starting to roll out things like Hadoop as a service, where you can offer a Hadoop analytics stack to your end user customers, and the more enterprise data sources you get stuck into your enterprise data hub, the more powerful the insight you get when you actually run your analytics there. So the trend that we see with our customers is they'll start out with 1 or 2 use cases, they see the initial success with Hadoop, and all the rest of the data sources start getting ingested into the Hadoop cluster, which actually gives them a tremendous capability for insight that they wouldn't have had before. And when you take a look at technologies like NoSQL, which offers a different kind of a clustering model, if you're going to go do something with Cassandra or MongoDB with one cluster, and then you have your separate Hadoop cluster, trying to get insight off of multiple clusters is a very technically challenging exercise, and it's much easier if you can just get all that data into one place, which is really what the enterprise data hub concept is about. So getting all those data sources into one place really creates a very powerful insight mechanism. It minimizes the whole process of kind of shipping data from one place to the other and then back again. So there's a lot of built-in economic advantage to this approach. And it enables one platform for analytics, which is really kind of what our tagline has been for quite a while now. So the next couple of slides really sort of drill down to this notion of an enterprise data hub and what are the attributes of an enterprise data hub. And time and time again, what our customers tell us they like about our platform is the fact that they can deliver a 5 nines, no single point of failure platform for making data available to a Hadoop environment. That's built into our platform. It's sort of table stakes for any serious enterprise deployment. We offer that out of the box with our capabilities. Share data and ensure that you can do a disaster recovery kind of a paradigm is also a critical function for our customers. And some of our very largest customers have bought principally because we offer that capabilities and there was no way to get it out of the box with any other distribution. And from a data protection perspective, it's amazing. Just yesterday, I actually had some discussions with one of our largest customers around how people can accidentally delete very large sets of data, and they have kind of an oh poop moment when they go, oh no, wait, I didn't mean to delete all that stuff. And if you actually have the capability to restore that by leveraging built-in snapshots, which is something that we offer in our platform out of the box, then the panic that you have over those moments is potentially significantly reduced. Okay. So another sort of list of different attributes associated with a truly reliable enterprise data platform capability. On the left hand, they really break down into reliable compute. On the right hand, they break down into dependable storage. Those are the 2 attributes that most enterprises look for when they want to deploy a new platform to support a new technology initiative. We offer all these capabilities out of the box. It's a challenge to get any of this stuff out of the box with any other distribution. And in most cases, it doesn't work very well. So that's why customers are coming to us to deploy their Hadoop solutions in production. Okay. We're getting close to the end of the presentation, and I'll be happy to take some questions after we get to the last few slides. But what we actually also see with respect to adoption of Hadoop in the enterprise is it's not really just about the traditional batch-oriented paradigm that Hadoop was designed to enable many years ago. That's traditionally maybe the enterprise starting point. So they might take a batch-oriented workflow and run that on Hadoop, and that might be their first experience with Hadoop. But very quickly, the focus tends to change over time to more interactive models, where people want to actually be able to do queries and get responses back in a few seconds as opposed to minutes or hours. So interactive use cases are really starting to pop up as a major area of interest for lots of enterprises. And then finally, kind of on the far end of that extreme, we also get many more levels of interest around real-time enabled workflows, where you've got sensors that are sending in data every 30 seconds from the field, and you want to be able to ingest that data and analyze it very quickly so that you can get up to the minute snapshots of what people are really doing. And a great example for that is brand monitoring, right? If you're launching a new product into the market, you want to be able to monitor what people are saying about your brand and about your product via social media mechanisms. So having the ability to actually understand how that's working and seeing how your brand perception is changing over time is a very, very powerful notion for most marketing departments. And that's a huge enabler for a lot of our business. In fact, if you stop by our booth after the presentation today, you'll see a demo that we have that my team put together, which is basically a real-time Twitter-scaping exercise where we're going through and monitoring what people are saying about an expression. You just type it on the console. In this case, I think it's Hadoop. And you can actually see bubbles changing as what people are saying about Hadoop is changing over time and who's saying it is changing over time. So it's kind of a very interesting dynamic application, and it's a proof point for our ability to actually ingest data in real time and analyze it as it's coming in. We're leveraging our built-in snapshot capability to do that. And we're also leveraging Storm, which is co-located with a Mapbar cluster, in this case on an Amazon footprint. So this ability to support a wide range of use cases from batch through interactive into real time, that comes with Mapbar out of the box, and that's another huge reason why people are looking to us to sort of facilitate the enterprise data warehouse offload motion. Okay, try it again. Here we go. All right, so this is sort of the summary slide, and I'll use this to really talk to the reference architecture, which largely looks like this for most of the customers who have gone through this exercise with Mapbar. So you see a number of different systems, not just billing and account receivable systems. Those are representative of what some of our customers are ingesting into a Mapbar Hadoop distribution. But basically the idea is take all of your legacy transactional data sources, run the ETL through a Mapbar Hadoop cluster, structure the subset of data that's interesting to you from a hot data perspective, run that in your data warehouse, and then connect up your traditional BI tools the way you always have to the enterprise data warehouse. So this is sort of the reference architecture that we see promoted and deployed in production over and over again. And we have a lot of different customers who are doing this. It's not just one specific customer I wanted to talk about today. I'll sort of survey I talked a little bit about a retail customer earlier in the presentation. We also have a very large computer technology vendor who has been historically doing their order operation analysis in about a 4 or 5 day window processing time, which is a very challenging thing for them at the end of a quarter. They would do that in 4 or 5 days on enterprise data warehouse. They're running it in about 2 hours on a Mapbar Hadoop cluster. So they're able to really shrink their analytics process from an order management perspective very significantly by taking this approach. And also allows them to, down the road, mine their supply chain much more effectively because this is a very complex supply chain for this particular customer. And they can now have the potential to look at multiple different parts of their supply chain and understand what the impact is of a change on one end to their ability to deliver product and sell it on the other end. So that's kind of a future deployment project for them, but it's a very critical one, very strategic for the company. We do have other customers in the telco space, and their ability to grow their business historically has been hampered because their data warehouse was so hot. They couldn't literally acquire new companies because they didn't have the headroom in their data warehouse to accommodate another data source from another billing system. And if you've ever worked in the telco space, you know that a large part of your business is really calibrated around managing all these different legacy billing systems and sort of making sure that they all are outputting data that makes sense. So that analytical perspective is a very important part of a telco business. And by operationally reducing your headroom or increasing your headroom by reducing the temperature, the companies that we have in the telco space that are customers of ours are allowed to actually acquire more businesses and grow their footprint worldwide. And that's a very significant strategic objective as well. So even though a large part of this talk has been around reducing cost. You can see that there's huge strategic benefit in reducing the amount of operational pressure associated with a enterprise data warehouse by front-ending it with a Hadoop cluster. So the quotes that you see down here in the bottom, 10x faster, 100x cheaper, that actually came from one of our customers in the computer technology space. That's what they saw with their early trials, and they're expanding it in a very dramatic way to include the supply chain initiative as an example. And they can do that without disrupting their SLAs that the IT department has signed up to. If you're in the IT business, you live and die by 5 nines, and your job is at risk if you can't deliver that. So they have found no way to do it with other distributions of Hadoop, but with us, they don't have to sacrifice that commitment. They can still keep to their 5 nines level of availability with their end user customer base and make them happy. And that's a huge enabler for them. And finally, the ability to sort of take not the entire ETL pipeline, but maybe a subset of that pipeline, so that you can minimize disruption to the end users who are still using the BI tools that they have known to love over many, many years. That's another huge advantage to taking this approach to reducing the cost structure and increasing productivity with enterprise data warehouses. Okay, so that's the end of my presentation. I went through it probably a little bit too quickly, but I haven't seen anybody fall asleep yet, so I guess that's a good sign. I'm happy to sort of spend a couple minutes answering questions from anybody in the audience. If you do have a question, please step up to the mic, because we're recording the session and want to make sure we can hear your question.
So the $30 million, was that essentially just because you're using a cheaper storage infrastructure?
Deferred storage cost, actually. Removed storage cost in this case, so that's exactly right.
Okay.
The bulk of that savings was on the storage side.
Okay, and then essentially you're creating MapReduce routines for your ETL, so you're not really partnering with any existing ETL vendor?
So that's a great question, actually. So what we see is a combination of customers using both legacy ETL technologies as well as off-the-shelf ETL technologies. So it's typically a mixture of both. It's very hard, especially with a very large organization, to sort of standardize on one ETL technology. There's a lot of legacy stuff that gets wired together with SPID and baling wire and whatnot, and that stuff can pretty much stay the same. In fact, we have one customer who took Teradata Parallel Transport, which is a utility that ships with Teradata, and they scripted a front end and back end around it and ran it over Mapbar, leveraging our NFS capability. And that was a key part of their ETL process. And that was a sort of hand-tooled approach for a specific part of their workflow, but it scales really well and you get great performance out of it. And they also use other off-the-shelf ETL technologies as well. So it's typically both. Good question.
Yeah,
Yes?
Actually, that led into my question also. So how you move the data from Mapbar into the targets?
Great question. So one of the biggest advantages of the Mapbar distribution for the Hadoop is the fact that we have built-in support for NFS. And for those of you familiar with NFS, it's kind of an industry standard protocol that you find pretty much in every enterprise. And it makes it very easy to get data from one place to the other. It's sort of the default protocol for remote file sharing outside of CIFS, which is what comes with a Windows environment. So pretty much every device on the planet has an NFS client these days, including my iPhone. So leveraging NFS as a sort of built-in de facto protocol allows you to much more easily get data in and out of the cluster both ways. And that's not exclusively how our customers use it, but that's the preferred way because it's so much easier than things like Scoop or Flume from an ingest perspective, which are the default ways to do it with traditional Hadoop stack. And we include those technologies, so some of our customers will use Flume or Scoop for certain parts of their workflow, but they'll use NFS traditionally immediately because it's the easiest way to get things done. Good question.
I was interested that you showed your BI tool on the last slide as connecting directly to the enterprise data warehouse, which is presumably a big relational database.
Right.
But the BI tools, you talk to Tableau, for example, they're quite happy to connect directly to the Apache Hadoop stack.
So you can do both, right?
But so that raises the question of where is your enterprise data hub that you're talking about that is a sort of a centralized resource? Is it, do you think of it as on the relational database, or is it really on the Apache Hadoop implementation?
So that's a concept that we implement with Apache Hadoop, right? So the idea is that when you use Hadoop as a platform for implementing the enterprise data hub concept, you have the ability to ingest data much more easily, and you can analyze it directly from technologies like Tableau, or you can use it as an ingest point for further, more structured analysis in an enterprise data warehouse context with legacy tools. So you can do both. And that whole notion of enterprise data hub is really something that Apache Hadoop enables as a platform, and our specific implementation of Apache Hadoop is proven to be very successful for it because we have so much great capability around availability and performance and other sort of traditional enterprise concepts.
Well, if the Hadoop stack is capable of solving the query performance issues, then that would seem to, pardon me for saying this, it would seem to raise a threat to the relational database as being a place where you need to then transfer the data to that point.
Indeed it would.
Not to raise a
That's a good
sensitive
observation.
issue.
So if I were in the relational database business, I'd be probably throwing around $500 or $600 million, see if I can buy some of the Hadoop distributions out there.
Okay.
In the savings part, were you able to actually shrink the relational data warehouse by putting some of it in the front ending it? Because otherwise that would continue to grow if you're doing like year-over-year analysis.
Yeah, absolutely.
You still have it.
So a large part of what I sort of talked about was the ingest process. It works the other way as well. So a large part of what we see from a processing perspective is going through your enterprise data warehouse, taking the data that's not really hot anymore and moving that out to your Hadoop front end. In fact, we're working with a number of different partners in this space who are creating automated ways to go through your data warehouse and find the stuff that's hot, keep it there, find the stuff that's cooler or cold, move it out to a Hadoop front end. So that migration process allows you to really reduce your storage cost.
And I got a second question.
Sure.
I'm in the financial services industry, and PCI is one of our worries. What are the encryption technologies that work in Hadoop at this point?
So great question. It really kind of depends on the distribution and the problem that you're trying to solve. And what we're seeing a lot of interest in is not necessarily encryption, but more around PII identification in terms of finding the sensitive data and stripping it or masking it out so end users can't see it. We actually have a number of different partners that we work with, one of which is Data Guys, and we've worked very successfully with them in financial services environments. So there's a lot of capability that we get in the ecosystem to help solve that problem.
The numbers for the storage costs that are associated with various systems, how recent are those?
So we literally get data points every week on that because every time we talk with customers, they tell us what they're spending. So I would say, those data points that you saw are probably at most 6 months old. The interesting thing is that they vary by vendor, right? So I actually had a meeting a couple of weeks ago with a customer in Boston who told us, really, only $10,000 a terabyte? We were actually spending $1 million a terabyte. And I was kind of scratching my head trying to figure out how you could sustain that. So that they must be calculating lots of other things into that particular price point around OpEx that maybe aren't there, but it tends to vary from vendor to vendor, but we've validated these numbers several times with our customers, and if anything, those are on the low end.
About the number that you had.
Oh, right, the $333 per terabyte? Yeah, so that price point really depends largely on how you're deploying the solution, and it can range a little bit depending on your infrastructure. So for example, if you're looking to deploy, say, a NoSQL solution, we have a NoSQL solution called M7, which is HBase on steroids. It's actually a fantastic platform. Using M7 tends to drive a lot of 10 gig type throughput. So if you're instrumenting your environment with multiple 10 gig interfaces, then that price point might go up a little bit. If you're just doing it with standard, white box hardware and a single or two 1 gig interfaces, then that price point might be a little lower. So it varies depending on the platform and how you're instrumenting your solution. I'm sorry, I couldn't hear the question.
That's representative of what you have seen in the market?
Yeah, absolutely. Thank you. Other questions or comments?
So I have a question on unstructured data. In Hadoop, we have unstructured data, right? How does it get stored into relational database?
So you'll typically go through, and this is a process that organizations will go through in different ways, but they'll identify the data that they most want to structure, and they'll go through a structuring process typically through ETL. So the ETL technologies that they're using will typically help them structure the data and load it into a more structured environment.
So are they using any conversion?
Yeah, I can't actually speak to a lot of the details there because I haven't been involved with it, but there's a number of different techniques that I understand are being used. Some of them come from off-the-shelf vendors, some of them are hand-rolled by customers themselves. Other questions or comments? All right, well, thank you very much for coming in. I'm glad to see that everybody stayed awake.